We're going to go ahead and start talking about factoring. Here's some helpful hints for you to follow when you're trying to factor something. For the most part, factoring means you're putting it back into parentheses, where simplifying is where you're trying to get rid of the parentheses. So with factoring, you're going to end up with something that has parentheses in it. You always want to start by taking out your greatest common factor, no matter how many terms you have. If there's only two terms, check to see if it's one of the specials, differences of cubes, right here, sum of cubes, or differences of squares. If there's three terms, then you want to try the AC factoring, where A is the number in front of your squared term, C is the number off by itself. You multiply them together, and then you want to find factors of whatever you got there that add up to B, where B is the number in front of X. If there's four terms, you want to try factoring by grouping. So here, we have three terms, but you always want to start out with that first step of greatest common factor. So is there anything that goes into all three terms? Well, you look at the numbers in front. You have a 10, a 15, and a 5. So you could pull out a 5. And then you notice with all these terms here, they all have A's in them. They also all have B's in them. So do you take out an A cubed to A squared or an A to the first? You always take out the smaller the exponent, because we can't take out an A squared because there's no A squared that goes into the last one here. Same idea with the b's. You take out the smaller the exponent. So we're going to take out a 5 and an AB. Then you have to ask yourself, 5AB times what gives you this first term? Well, 5 times 2 is that 10. And A times what is A squared? And that's an A times an A squared is that A cubed. And then B times what is B squared? And that's another B. We then have that big plus sign, and then you got to repeat. 5A times what is your 15A squared B? So 5 times what is 15? That's a 3. A times what is A squared? That's another A. B times what is B? And that's a 1, so we don't have to write anything. Then we have our minus sign. 5 times what is 5? Is 1. We don't need any more A's because A to the first times anything would give you an A to the first. And then your B times a B squared is your B cubed. Sometimes after you pull out your greatest common factor, what's left in the parentheses you can factor farther. In this case, you can't. Top right one here, you want to see if you can pull out anything out of all four terms. There is no greatest common factor other than 1 here, so pulling out a 1 does not help you. You'll notice it's four terms, so that's where you want to factor by grouping. You want to go ahead and see what you can pull out of the first two, and in this case you can pull out an x squared. X squared times an x is that x cubed, and x squared times my 5 is that 5x squared. What can we pull out of the last two here? Well, they're both negative, and I can pull out a 2. So I'm going to pull out a negative 2. Then I need to look at what's left. And negative 2 times what is x, or negative 2x, and that's an x. Negative 2 times what is negative 10, and well, that's my plus 5. Now, we're going to take a side note and come back to that. So if we take a look over here, you'll notice if we wanted to factor something out here, A is a common factor. So I can pull an A out of here, and then I'd be left with the darker colors of an x squared and a minus 2. When I look down here, you'll notice what's my common factor I could pull out, and that's triangle. So I could pull out triangle. What am I left with? An x squared and a minus 2. Well, what I have down here, this last one, is also very similar to what I have up here. I have an x squared times something minus a 2 times that same thing. So what I have here in green is really like that common factor that we had down here in orange. So I'm going to pull out that common factor, the green. What am I left with if I pull that out? I'm left with the blue of this x squared and the minus 2. So pulling out that common factor, the green parenthesis goes in front, leaves me with the blue, and that goes right here. So that's factoring by grouping. So go ahead and try to do this one on your own and then play the video. Pulling out your greatest common factor here of an x and a y squared. What are you left with in the parentheses? Well, xy squared times what is this first term? Then we have our plus sign. And xy squared times what is the second term? Subtraction sign. And xy squared times what is an xy squared? And that's a minus 1. Go ahead and do the top right one here if you've not done so. Pull out your common factor out of the first two. Since there's no greatest common factor, we're going to use grouping, and we pull out an x squared times an x minus 3. Out of the last two, we can pull out a positive 4. And notice both parentheses are the same, so we're on the right track. So we can pull out that common factor, which I just changed the colors here. Common factor is the green, and that's going to go in one parenthesis, and what's left in the blue goes in the other parenthesis, and that's what we have. So we'll start off with this one here. Once again, pull out your greatest common factor, which in this case is a 3 and an x. What am I left with? I'm left with an x squared minus, and then 3x times what is 12x, and that's a 4. Now sometimes when you pull out the greatest common factor, you can't do anything else with what's in the parentheses. But what we have left in the parentheses is a differences of squares. Differences of squares is like what we have right down here, and it factors into whatever's being squared here in the beginning, that goes in the beginning of each parenthesis. Then you have a subtraction and a minus, and then whatever is being squared here at the end, that's what goes in the end of the parentheses. So as we look here, in the beginning of our parentheses is an x that's being squared. In the end, it's a 2 that's being squared. So when we factor this, we're going to still have a greatest common factor. What goes in the beginning of each parenthesis is what's being squared, which in this case is an x. And then one's a plus, one's a minus. What goes in the end of each parenthesis is what was being squared. At the end, what was being squared? It was a 2, so we put a 2 at the end. And then we're done factoring that. Top right, you look for a greatest common factor. There is no greatest common factor other than 1, and that's not going to be helpful. So then we go ahead and we try to factor this. And you'll notice there's 2 terms. So we want to check to see if it's one of these specials down here. Now, differences of cubes and sum of cubes factor into very similar ideas here. For differences of cubes, whatever's being cubed goes where all the boxes are. After the subtraction sign, whatever was being cubed goes where all the triangles are. Similarly with sum of cubes. You'll notice these right here are very similar. However, the subtraction sign here is going to match the subtraction sign in the beginning. Plus sign here will match the plus sign in the beginning. The second sign here is always opposite the first sign. You'll notice the same down here. The second sign is opposite the first sign. The last sign is always plus. This is really a sum of cubes. It's really an x times y all being cubed and a 2 that's all being cubed. And we have a subtraction sign, so it's differences of cubes. So what's being cubed in the beginning? That's an xy. So we're going to replace all these boxes with our xy. So we'll also have an xy here for that box and an xy here for that box. Our triangle correlates to what was being cubed at the end, and that was our blue 2. So each one of these triangles down here gets replaced with a blue 2. Sometimes you can do a little bit more simplifying. We can't really do anything here in the beginning. Here, this was our, whatever was being squared, our x times y. We can actually apply the squared to each one, and we get in x squared, y squared, plus, and then this right here. It's common practice to put the 2 in front of your variables, so that's what I'm going to do. And then here, we're going to have a 2 squared, which I'm going to write as 4. Now, you might think that the second set of parentheses in sum of cubes or difference of cubes looks like it'll factor farther yet, but it never will. You can try as much as you want, but it never will. But this is what we get when we factor it. So once again, I have differences of cubes, sum of cubes, and differences of squares. So this one right here, just as a side note, is really differences of squares, because it's really an x squared minus a 3 squared. That's going to factor into this here. What's being squared in the beginning is an x. You're going to put that in the beginning of each parenthesis. What's being squared at the end is a 3. You're going to put that in the end of each parenthesis. One of the signs is plus, one of the signs is minus. Doesn't make a difference which one. This one here is really sum of cubes, which matches the bottom one, because 27 is really a 3 cubed. So your box is what's being cubed, correlates to x, because that's what's being cubed. At the end, what's being cubed is your triangle. That correlates to 3, because that's what's at the end that's being cubed. So you're going to replace all your boxes here with an x, and you're going to replace all your triangles here with 3's. And then we're going to simplify a little bit. Nothing in the first one, nothing there. It's common practice. Put the number in front of your variables, plus, and then 3 squared you're going to write as 9.